This is proof running on the real project. What you're looking at isn't a normal code graph. Proof isn't just showing that one function calls another. It has turned the repository into components and a graph of intent. What the software is supposed to do, what those requirements depend on, and what proves that they still hold. This is the component responsible to GitHub interaction. A component in proof owns responsibilities. It has requirements, open issues, changes, hazards, and evidence around the behavior it is responsible for. In this public project, this component has two requirements. Let's open one. This requirement describes how to validate GitHub links and its API content. The important part is that this is no longer a sentence sitting in a document. It is formalized as mathematical formula, has information about approvals and history of all modifications. It has hazards and proof obligations. Moreover, proof force tests to be written for every claim it makes. Proof knows which code implements it, which tests provide evidence, and which past defects changed our understanding of it. So the requirement is the anchor. The code, documentation, issues, changes, and evidence hang from the intent, not the other way around. Now I can ask a different question. If this behavior changes, what else may need to be reconsidered? Proof gives me the blast radius, the affected requirements, files, tests, documents, contracts, and obligations. A code graph tells me what calls what. Proof tells me what depends on what being true. Now let's open one of the known issues found by proof. Now let's look at a problem that has not been fixed yet. In proof, that remains an issue. It is connected to the requirement it violates, the component, the hazard, the relevant code, and an executable reproducer. Proof does not hand the engineer another comment saying the code looks suspicious. It gives us a command that fails on the affected code. The issue is real before anyone starts fixing it. Now let's switch to the real coding agent connected to proof through MCP. Try to fix one of the issues. The coding agent has access to the same graph through MCP. It does not have to start by rereading the repository and trying to reconstruct the architecture from raw files. It can ask proof, what does this component promise? Which requirement is violated? What depends on it? What has failed here before? What is the reproducer? And what evidence will be required before the work is complete? Issue is fully fixed now. We can see that agent added required evidence and tests. Now let's go back to the dashboard. Once the fix is verified, the issue does not merely disappear into a done column. Proof creates a defect record. It uses the same evidence-bearing structure as any other change, but now it also retains the original issue, the reproducer, the root cause, the actual fixing change, and the evidence that closed it. Closing the class requires broader evidence, the relevant hazard analysis, sibling sweep, requirement obligations, and the rest of the blast radius. If that evidence is not there, proof says so. It does not upgrade one green test into a claim we have not earned. The next engineer and the next coding agent will inherit the reproducer, the fix, the hazard, and the evidence instead of discovering the same lesson again. And that is one requirement, one change, and one defect inside a much larger system. That is what we mean by requirements that test themselves. But the bigger idea is this. Proof is a living record of what the software must continue to do, and every consequential change has to bring the evidence with it. And your agents get the same map.